Device offers promise of no brain tumor left behind. Vertical line body brain vertical line science news. Subscribe archives register log in. Atom cosmos. Body brain. Earth. Environment. Genes cells. Humans. Life. Matter energy. Molecules. Science Society. Other. ESN Kids. 09 vertical line 21 vertical line 13 issue. Contents collision course. Scientists struggle to make windows safer for birds. The tune wreckers. Lousy singers make the pitch for scientific relevance. Subscribe. Give a gift. Renew. RSS feeds. Email alerts. Digital edition. Podcast. Past issues. Read articles, including science news stories written for students, on the SNK website. Contents alien cart leap onto the scene. Invasive fish break people's bones and threaten native species. Video games. When Granddad wins. With some practice, people over 60 bested untrained 20-year-olds meet the new meat. Scientists made a hamburger without harming animals, but it cost as much as a house. Home/news. Device offers promise of no brain tumor left behind. New technique might allow surgeons to identify edges of cancers. By Nathan Sepa. Web edition, September 5, 2013. A+A, text size. New technique might allow surgeons to identify edges of cancers. By Nathan Sepa. Web edition, September 5, 2013. Enlarge. The cutting edge. A new technique generates colored images that differentiate tumor tissue blue in the mouse brain from surrounding healthy tissue green. The technique may eventually improve brain surgery. Credit, G et al/Science Translational Medicine. The tiny probe equipped with a laser might reveal what the human eye doesn't always see, the difference between the tumor and healthy tissue. A new study suggests the device might provide brain surgeons with a roadmap as they go about the delicate business of removing tumors. Surgeons try to excise as much of brain tumors as possible, but they risk harming the patient if they remove healthy tissue. This problem, says surgeon Daniel Orr of the University of Michigan in Ann Arbor, has vexed brain surgeons for as long as they have taken out tumors, since the first half of the 20th century. Basically, we do it by feel, the texture, color and vascularity of the tissues. Tumors tend to bleed a little more than normal brain. Although removing and testing tissue samples, or biopsies, can help to characterize the tissue at the tumor margins, it's a cumbersome and time-consuming process. In the new study, Orr and his colleagues instead exposed such borderline brain tissues to a weak laser. Then they used Raman spectroscopy, the technique that reveals vibrations of specific chemical bonds in tissues. The revved-up form of Raman spectroscopy that the researchers used is sensitive enough to distinguish between proteins and lipids. Since tumors are higher in protein than healthy brain tissue, the authors designed the technique to present protein signatures as blue images on a screen, and lipids as green. Enlarge. Discerning tumor from healthy tissue in brain cancer is tricky. The pink image left shows what a surgeon sees with a microscope, including branching blood vessels. At right is the same piece of tissue viewed using Raman spectroscopy to delineate tumor tissue from normal tissue. The tumor edge is marked by a dashed line. Credit, G et al/Science Translational Medicine. Using the device as a probe, the researchers examined human brain tumor cells that had been implanted in live mice. The device could distinguish where the new tumor ended and healthy tissue began. A separate analysis of tissue that had recently been removed from a human brain cancer patient similarly revealed stark differences between the tumor and normal tissue. The findings appear in the September 4 Science Translational Medicine. The study offers a very exciting advance, says chemist Ji-Sin Cheng of Purdue University in West Lafayette. The research establishes that visualization of the tumor margin using Raman spectroscopy is possible in a living animal, he says. In patients, this could streamline surgery, says study co-authors Uneasy, a physical chemist at Harvard University whose team developed the new imaging technology. We don't need a biopsy, he says. You can do it in real time. Z and Orr estimate it could take 5 years or more of testing to get regulatory approval to use the technique with patients. Comment. Citations. M. G et al. Rapid, label-free detection of brain tumors with stimulated Raman scattering microscopy. Science Translational Medicine.